ipX's Elliot here at Hardware Pioneers Max 2025. In my opinion, engineers are not lazy, they just don't love to read, and there is no more excuses to be a cowboy, because today we're talking to Michael from Embed. Pleasure to meet you.
Hey, Elliot, how are you doing?
Yeah, great. Can you tell us a little bit about your platform and sort of why engineers would want to use this?
Yeah, absolutely. So we are giving engineers a tool that can get you from datasheet all the way to a functioning driver and functional testing, all in a matter of minutes.
So you're telling me no more reading data sheets?
Just a tiny bit, but it's a very different experience from what you've seen before.
Okay. So it's no longer slugging through long lines to sort of learn all the start bits and stop bits and all the I²C functionality speed. You're saying that you have something here that will read all of that for you.
Yeah, exactly. And we'll give you a neat visual interface that you can configure your component with. So there's a digital model of the component. So you select your interfaces, you configure your registers, you do your setup of the initialization, events, everything. And then you can, in a matter of minutes, bring it up on an MC or dev kit of your choice, and then generate a driver library for it and go into production. So probably something that would take you a few weeks to do, now it can be done in a matter of minutes.
Amazing. So how do you do that? Is it AI that will sort of read through the data sheet and then generate the code?
So the way it works is the first step is going from the data sheet to a digital component model. That's where we leverage AI. But from there, when you configure that digital model, you can actually generate driver deterministically. So there is no AI hallucination in the code itself. So no ChatGPT situations where a couple of thousand lines of code generated and you don't really know where the mistake is sitting, and you're struggling with a headache of trying to find that. Here, everything that you've configured and tested within the digital configuration is then mirrored in the code that you generated. Plus, that code could be adjusted to the specifics of your architecture, your RTOS, your code styling, you name it.
Beautiful. So you can take this from an AVR project to an STM32 to any sort of microcontroller. It's completely agnostic.
Yeah.
And any sensor as well?
Yeah, so basically, right now we support I²C and SPI based devices.
Yeah.
So all of the sensors, IO expanders. We are adding UART, so that's something that's been asked for quite a while. And that is unlocking all of the communication devices as well.
Yeah. So we've got everything here. We can talk over I²C, SPI, and eventually we're going to have UART when that comes. Say I want to get started with this today. How am I going to do that? Is it some sort of extension you can do, or is it an online web browser? How does it work?
So there are two options available right now. There is a VS Code extension that you can plug into IDE that probably you're already using.
That is so easy.
If you're not in VS Code for some reason, you can go to our cloud-based version. So it's a browser hosted, so you can just go. It's actually a mirroring of VS Code. So you'll have a very familiar feel if you've ever used it, and then just use it across sort of any IDE environment that you might have.
Wow, what a crazy advancement we have. This might mean you don't have to write a .h ever again, and that means a lot for the engineers who are slugging through data sheets, who are struggling to find out why their stuff isn't working. I mean, you should really try this before you even try and write it yourself. Can we see some sort of demo of what you've got?
Let's do it.
Michael from Embed has prepared a demo for us to show how easy it is to get started with their software. What are we looking at right now? Is this VS Code as we know it?
This is actually a browser-based version. So I just go to platform.embed.it, and then you get here, you log in, you have all of your components that you've previously processed in your component library. That will include all of the configuration, drivers, testing. But what I can show you now is how we go from very beginning. Let's say we have a new component, this analog devices accelerometer, ADXL345.
Yeah, cool.
Let's say we want to bring up and test and generate a driver for this ADXL. What do? We go to the bottom left corner and click Upload Datasheet. Select the datasheet we want to upload here. So I select ADXL, and what's happening now is we are processing that datasheet into a digital component model. What it means is that we retrieve all of the information about it, interfaces, register map, events, everything. It then becomes available in the form of a configuration. So if I scroll down, you can see ADXL345 in the bottom. If I open documentation, there is our datasheet that we uploaded.
Can we open up the PDF to actually see it? You're not hiding anything here. That is a PDF.
That's a PDF we uploaded.
Beautiful, as boring as I know them.
It is, absolutely.
Just scroll down just a little bit. Oh God, could you imagine reading all of that?
Yeah, absolute nightmare.
Not anymore.
So here, I open the configuration. And what I have here is a system that's split into chapters.
Yep.
First is general information, device name, vendor, class, interfaces it supports. So we've identified that it supports I²C and SPI.
So it's ripped all of this information for you. This is nothing you've filled out. That's wow.
That's just retrieved for you. So let's say here I've connected with the I²C. I can then configure it. There are all of the addresses that it can be connected to.
Right.
I can select frequencies. There is register map. All of the registers that this device supports are offered to you here. So for any register, I can see straight away the name, address, size. But if I open it here, you'll see the delays types, access types. You can change anything, all of the bit allocations as well. So here, for example, sleep. And I'll be able to see all of the fields that are related to that. And all of this is adjustable. So you can easily configure it. So you just want to say, hey, actually, I want this to be size 1 and I want to create additional reserved offset. You can do that very quickly. All of this is also backlinked to the PDF. So if you click PDF and you actually want to see more context for it.
Yeah, you want to prove it for yourself.
Yeah, you want to see backlink and say, hey, what's power control? Within a second, you'll see detailed information on power control, what that does, and sort of allows you to configure it better.
Amazing.
You then have your commands, if they're present in device, data types, events, like physical pin interrupts, formulas, and setup. So setup here, for example, allows you to select the registers that you want to use to initialize. So in this case, I can select power control, BW rate, for example, and add them to my setup list. If I open the power control here, I can see that the device is in normal mode. I can save it in sleep mode. So now it's measuring in standby mode, but I can switch into measurement and we'll automatically calculate your decimal values for it. You can also change sequencing here. So you can set it up the way you want it. Plus, here, let's say, frequency at which we are pulling it, I can change it really quickly to whatever frequency I want to use and we'll recalculate it for you.
Wow.
Finally, there are formulas. So you can combine registers. So you can select registers. In this case, this is an accelerometer and it comes with 2 registers to read 1 value. So if I just create x-axis here.
So for instance, if you had a 16-bit number or,
it's a 2 8-bit registers that need to be glued together for you to be able to do that. So I can just select data x1, data x0, and we'll create a combined value for you. On top of it, you can then process that. So you can get, say, x, and then you can insert that register and do whatever computation you want to do with this. So I don't know, delete by, divided by 100, for example. You can say that. So you can have both raw values and processed values that are then generated for you.
Right, okay.
Finally, we've configured it. We are happy. We want to see, okay, if it's actually working. So first thing I'll do, I'll click Generate Testing. What testing is it facilitates immediate bring up of that component on hardware. So for that, you'll need a dev board of your choice. So in this case, as mentioned, I have this Renesas board. And my ADXL is connected through I²C. So I just select the board I want to connect. In this case, is array 8 and 1. And then I click Connect, select the COM port I'm using for this. And now you see that it's connected. It scanned all of the buses, identified the address. I can straight away see all of the live readings for registers. So each register you will see how values are changing. But nicely enough, you can go to time series, select the register name, let's say x-axis, and then it will give you live reading on that. So I think I just disconnected it, but the usual
point, we've seen that move around.
Effectively, you'll see live data being read off that, and you can very quickly validate it, whether that's on your processed values or on your raw register data.
What a great way. This is very similar to the serial plotter that they have in an Arduino IDE, which a lot of other IDEs don't just have available for you. This is a fantastic way.
And that gives you all the way down to the actual register level data, so you can debug it and validate it very quickly. And then if you are happy with it, you can disconnect it, go back to your configuration, and say, actually, now I need a driver. So you click Generate a driver.
Give it to me.
Select the project options, the language, HAL architecture, memory allocation strategy, controller by Torus. And here we can support more. So for enterprises, we can support your custom architectures, maybe your RTOS or specific code styling.
Beautiful. I see you've already got like Zephyr and CMS there. Beautiful.
Let's go CMSIS, for example. So I select that and I click Generate. So from here, we deterministically generate a driver library. What it means, as I mentioned, is there's zero AI in the way that code is generated, meaning it's predictable, and you can have a library that's ready for you to use, header files. All
Commented itself as well.
All already commented with Doxygen compatible, so you can generate Doxygen out of that as well. And you have everything from headers to register implementation to your bus specific C file and CMSys integration. And if you want to go back and change it and say, hey, actually, this register, it needs to be called Elliot.
That's a great name.
So, and then we want to generate a new driver. And now we want to have, I don't know, bare metal.
Why not? Sounds good to me.
And let's generate a new driver. And within a second, let's say register header. So now you have your Elliot.
Beautiful.
Read delay.
Made after me. Beautiful. Amazing. ipXchange, this is huge. This is an opportunity to never have to write a .h again. Or even if not that, it's an opportunity to test out multiple sensors. You know, you start right at the beginning of a project and you're not sure which accelerometer you want to use. Go ahead, buy all three of them, and use something like what Embed has to quickly get them up and running. This is amazing.
Thanks, Elliot.
Michael,
Pleasure talking to you.
Thank you very much for your
Have a great day.
Cheers.
Thank you.